Okay, I'm going to show you now how to go from grams to molecules. So because we're using grams, or because we have grams in this particular problem, you're going to need a periodic table. Okay, super important. So with the periodic table, that's going to allow you to calculate the molecular mass, or the formula mass as it's sometimes called, of the substance you're dealing with. Okay, so you need to first find a periodic table and then add up the masses of the elements for that substance. Now that's going to tell you how much is in 1 mole of that substance. Now to go from moles to molecules, right, which is kind of step 2, you're going to need to use Avogadro's number. Now Avogadro's number is always the same. It's 6.02 times 10 to the 23rd particles. And in this case, the particle that we're dealing with is a molecule, right? Particles can be other things too, but in this video I'm showing you a particle called molecule. So 6.02 times 10 to the 23rd molecules. All right. Now, remember that this number, Avogadro's number, is going to tell us that 1 mole of any substance has 6.02 times 10 to the 23rd molecules in it. All right. So if I have, whatever substance that you're dealing with in these kinds of problems, that Avogadro's number tells you how much is in 1 mole of that substance. Now this may sound like a little weird because I'm not really showing you very much on how to solve the problem. So let's get into the video, watch the video on how I actually solve a problem using this information, and then at the end it'll probably make more sense. Okay, time to show you grams to molecules. Let's read the problem first. Here it says how many molecules are in 100 grams of water, which is H2O. Now, if you're going to solve a problem that involves grams, remember to have a periodic table handy. Okay, if you don't have a periodic table handy, find one, hit the pause button and then find a periodic table, and then come back when you have a periodic table in front of you. Okay, because I'm going to show you some things there. The other thing that you want to keep in mind here is that we are going to solve the problem in 2 ways. The first way that I'm going to show you is the dimensional analysis style, and then the second way I'm going to show you is by using a little magic triangle. And either way that you find works for you, works for me. All right, so let's set this up first with the dimensional analysis style. We're going to start with 100 grams of water, so that's 100 G, or grams of H2O. Now we need to have some kind of conversion factor that allows us to go from grams to molecules. Now you don't have a way to do that directly, so what you have to do is you have to take an intermediate step. Okay, so what we're going to do this in the dimensional analysis style is we're going to first start with grams. But then what we're going to do is we're going to take an intermediate step and we're going to visit the moles. Then once we get there, then what we're going to do is we'll get to the molecules. All right, so we're going to need 1, 2 conversion factors in order to get to the molecules. All right, think of this mole as like a central pit stop where you can convert between grams and molecules. That mole is very important. And one other little side note, mole is different than molecule, as you will see. Okay, so how many grams are there in a mole? Well, it depends on the substance, because here we're dealing with water. So we need to find out its formula by using the periodic table. So here's hydrogen. Hydrogen has a mass of 1.01, and since it's H2, we have to write that twice. Now the mass of oxygen is 16. Okay, it's way over here on this side of the periodic table. And so we have to add one of those into the mix. So let's put 16 here. And our grand total is 18.02 grams per mole. So that tells us that for every 1 mole of water, H2O, we've got 18.02 grams of water. Now this is a good step forward. The grams cancel, but we're left with moles of water, not molecules. Okay, we're not there yet. We need one more conversion factor to get there. And the important trivia that you need to know is that 1 mole of anything, 1 mole, is equal to 6.02 times 10 to the 23rd of whatever it is you're talking about. And in this case, we're talking about molecules. So I'm going to write 1 mole of H2O here because I want to get the moles to cancel. And then I'm going to write 6.02 times 10 to the 23rd molecules of water on top. Okay? So that's how I'm going to leapfrog from moles to molecules. So now, how do we figure this out on the calculator? Well, you're going to multiply the tops, and then you're going to divide the bottom numbers. So you start with 100, and then you're going to multiply by 1, and then you're going to multiply by 6.02 times 10 to the 23rd. So you can type in 6.02, and what I do, and what I recommend you do, is use this second function EE key to represent the times 10 part of this number. Then you type in 23 because this is raised to the 23rd power. And that's something that the calculator understands. Then you're going to divide the bottom numbers. So you divide by 18.02, and you can divide by 1 if you want, but we all know that dividing by 1 doesn't really change anything. So this becomes our final answer. Okay, now I don't have any space here, so I'm going to just write my answer in down here. And this is how many molecules of water there are. Oops. Now, I made one little boo-boo in here, and that is if you take a look at my number, there's actually some scientific notation tacked on the end of it. So let's get rid of this and let's write the right answer, which is 3.34 times 10 to the 24. You see, the calculator is going to speak back to you. So if you see this E24 here at the end, you need to actually check and see if it's there. But if it is there, then you need to make sure that you put that on the end of your answer and you translate this back. Okay, so this is the correct final answer. Sometimes students do what I did, and they just write 3.34, and they're so happy that they got the answer. But don't forget, there's a possibility, especially when dealing with molecules, that you have lots and lots of them. So don't be afraid that we got a big answer here. Okay, so this is the dimensional analysis style of doing the problem. Now, to do the problem another way, we're going to need to evoke 2 magic triangles. Okay, so let me describe what they are, and I'll show you how they're used. First is, just like in the previous problem, we need to go from grams to moles. So we need to set up a triangle that looks like this, and I'll change color just to emphasize what this looks like. Okay, so one of the triangles that we're going to need to use is going to look like this. We're going to divide the triangle up into 3 sections, and we're going to need to go from grams to moles. So moles is going to go in this part, grams is going to go up here, and the gram formula mass, see if I can fit this in here, gram formula mass, there we go. All right, we're going to use this triangle first, and then we're going to use this other triangle, and this triangle is going to be a little different. Okay, again, divided into 3 sections. We're going to put moles here. We're going to put molecules here. And we're going to put 6.02 times 10 to the 23rd here. Okay? So, let me show you how we are going to substitute the numbers in. Okay, so take my triangle here, and I'm going to now put in the values that go along with the parts of this triangle. Okay, so we know from the problem that there are 100 grams of water, so I'm going to write 100 grams up there. I'm going to need to start finding this moles. I have to find how many moles there are first. And I already know the gram formula mass because I calculated that in the previous problem. So I'm going to write 18.02 grams per mole there. Okay, so I'm running out of space, but I can probably squeeze this in. Just write X moles of H2O equals, now watch this. See how 100 is over 18.02? I'm going to write that same thing over here. 100 over 18.02. Now I'm going to need my calculator. So my first step is to do 100 divided by 18.02. Okay, so this is equal to 5.55 moles of water. Now remember, moles is my intermediate step. If you remember our little map here, we went from grams to moles, then we got to go from moles to molecules. Well, it's the same thing down here, but I need to use this triangle in order to do that. So let me set up my triangle again down here. I'm going to bring it in a little bit closer. And so I'm going to break it up into 3 sections. And since I'm looking for molecules this time, I'm going to put X molecules up top. Okay? And then here, I now know the moles. Okay, that's what I had down here. So I'm going to put this piece into this piece of the triangle. Okay? And then what goes down here is always the same. It's Avogadro's number, which is 6.02 times 10 to the 23rd. Okay? And then I'm going to set up my problem and morph this triangle into an algebra expression, just like I kind of morphed it over here. Okay? So this is how you set it up on this side. What you do is you write 5.55, okay, is equal to X over 6.02 times 10 to the 23rd. Okay? So if you're good at algebra, you should know that to solve for X, we're going to multiply both sides by 6.02 times 10 to the 23rd, and that will allow us to get X by itself. So I'm going to take my answer from the previous problem, and nice little shortcut key is to use second function answer. Okay, so that takes into account the answer from the previous calculation. And I'm going to multiply by 6.02 second function EE23. And look here, I got the exact same answer as I got before. See this 3.34 times 10 to the 24? Look here, I got the same answer, 3.34. And then again, E24 means that it's times 10 to the 24th power. So I guess it's a little cramped to write this here. I'll do my best. 3.34 times 10 to the 24. And of course, this was molecules of water. And so this right here, this is my final answer. Okay, so you can see which method works best for you. Okay, if you prefer using the dimensional analysis method, then that's great. If you prefer using the system of triangles, that's great. So just do whatever works best for you and make sure that you're consistently getting the correct answer. Okay, you just got done watching a grams to molecules problem. Congratulations, you survived. Okay, so you probably realized that in this problem you had 2 conversion factors, right? One to go from grams to moles, and then the second one to go from moles to molecules. Now, if you're going to solve a problem like this, you need a periodic table. And then with the periodic table, you can add the masses of the individual elements and figure out how much is in 1 mole of that substance, right? How many grams are in 1 mole of that substance? Now, from there, you can create a conversion factor and then use that conversion factor to go from grams to moles. After that, you need Avogadro's number, because Avogadro's number tells you that 1 mole of any substance is 6.02 times 10 to the 23rd. So if I have a mole of water molecules, for example, that tells me I have 6.02 times 10 to the 23rd water molecules. Like counting them individually, that'd be a lot. All right, so that's the basis for bringing in Avogadro's number. It can be used for molecules, it can be used for atoms, and it can be used for ions. It can be used for all types of particles like that. But in this video, we showed you molecules, so the 6.02 times 10 to the 23rd refers to how many molecules are in 1 mole of that substance. All right, so if you need more practice, download the worksheet, see if you can solve the problem the way that I did, and then reinforce by practicing other problems that are similar, okay, and check your answers to make sure that you're getting them right. Okay, that's all I have for now. I'll see you next time.